Hello, this is going to be me trying to answer a really common question, which is about how you write pseudocode, or what even is pseudocode. It comes up all the time, so it's obviously something which perplexes students year after year. I also think it perplexes teachers to an extent, because often I've spoken to teachers who are confused as to why their students find it difficult, because it seems like an obvious concept. When you have more context, when you understand its purpose, it seems like a easy to grasp idea, but when you're a student, certainly I think that's not the case, and I know it wasn't for me when I learnt it. It was just sort of mentioned out of the blue by my teacher. Didn't understand what it was or how you write it or what syntax it had, so let's try and clear it up now. I have previously made a video on a very similar overlapping question, which is about how you answer the algorithm questions, so the longer mark questions which often appear towards the end of exams, they're 7, 8, 9, 10 mark questions, and lots of people find them difficult. I think partly because you're often going to be writing pseudocode to answer them, so there's a lot of overlap. I spent a lot of time in that video talking about pseudocode because I know that it's difficult. So this is going to be a slightly more high level, maybe even more practical. I'm going to show you some examples of me going through it. This was more just me showing you some slides like usual, but I want to show you some examples of pseudocode in real life and also go through a few of these questions focusing on pseudocode specifically. But this may be useful, and if you've watched it, there'll be some overlap. But for the time being, just to give a very short answer to this question, how do you write pseudocode? Well, don't worry about it. It's really not a big deal. You don't have to. It's not something you have to really think about. That's the whole idea. It shouldn't be, the actual writing of the pseudocode shouldn't be the stress point. And the clue is that pseudo, the prefix, comes from the Greek word, which I think you pronounce as pseves, which means false or fake, etc. And even in normal English we have words like pseudoscience, pseudonym, which imply something not being quite true. So pseudocode is not an actual programming language, it's fake code. So it looks like code, but it doesn't belong to an actual language like Java, Python, C++, etc. These actual programming languages have a very strict syntax, the syntax being the kind of rules of the language, the things you've got to follow for it to work and to translate to machine code. So for Java, this is some Java code, you have to put a semicolon after every statement. That's just part of its syntax. And I've forgotten to put one here, so the IDE has come up with a syntax error. When I try and run it, we get an exception, we get an error because we've broken the syntax. Pseudocode doesn't have a syntax, so you can't have these sort of errors. It doesn't matter. There are reasons why we've got semicolons in Java, but it's not essential to this code having a semicolon from an understanding point of view. And this brings us to the main purpose of pseudocode, which is to be a high level, an abstract, way of representing an algorithm without tying it to a specific language. We don't want to limit the algorithm we've written to being just used in Python or just used in Java. If you see an algorithm written in pseudocode, if you are a good enough programmer, you should be able to implement it without too much difficulty. So the actual value of an algorithm is how it works rather than how you need to get it to work on a certain machine or by using a certain language. It's regarded as high level or abstract because we're simplifying the problem. We're not dealing with all the nitty-gritty details that having a set syntax brings. You'll know from your own programming that there are lots of annoying things you have to do, like put a semicolon, like having to indent it, which if you mess up, your code won't run. We don't really care about that because that's not important to how the algorithm works. It's important on how you actually implement it, but anyone can do that. It's the important bit, the valuable bit, is how it works. I think some of the confusion arises from the fact that exam boards do stick to a syntax, kind of. i.e. they'll have in exam papers pseudocode excerpts which all look very similar, i.e. they all follow the same scheme. And that's because exam boards have to be very standardised, right? They can't just one year create a different paper. Every year there are probably different authors, so different questions are written by different people. They've got to make them look consistent, otherwise there'll be questions asked by students, teachers, parents, etc. So we've got to be very standardised, which doesn't really lend itself to the actual use of pseudocode in the wider world, outside of just, school exams. It's not just that this very rigid looking pseudocode is included in questions, but also in mark schemes. So these are from OCR A-level computing papers, so the old course, by the way, and in mark schemes answers will be given using, in this case, OCR's specific pseudocode. So you might compare your answer to this example answer and be a bit confused as to why it looks different, and you might think that you're wrong just because it looks a bit different to how they've done it. But really it's the substance which is being mocked, not whether you've capitalized function, whether you've done end if at the end of the block. It doesn't really matter, it's the actual functionality which is important. Most exam boards allow you to see their kind of standardized version of pseudocode in the specifications. So in the case of OCR, or almost all of them, it's towards the end. So if we go down here, this is the OCR A-level new course specification. And actually here it says a really nice paragraph which sums up what I've been trying to say so far. So although it gives us a guide of the pseudocode that examiners are going to be using, it says you're not expected to memorize the syntax of this pseudocode, because actually that doesn't really make sense outside of the exam board. And when you're asked to provide answers, you can do it in any style that you choose, providing its meaning can be reasonably inferred by a competent programmer. So anyone who knows how to program should be able to understand what's going on. And certainly, if you learnt this syntax, which I wouldn't recommend, you'd be able to understand what's going on. But equally, if you did things a little bit differently, that would be perfectly fine too. I now want to show you some real-life examples of pseudocode in action, because if you're doing this for GCSE or A-level, your scope is quite limited. You won't see the full context necessarily. So this is a university textbook, a very famous AI one. It's in its 3rd edition, but it was first written in the 90s, I think possibly early 90s. You can see we've got Alan Turing here, who was one of the first people to really think about AI, and you've got robots and so on. So a very long textbook, over 1,000 pages long, and it will use pseudocode to express the algorithms that are part of this topic. So machine learning algorithms, ones which take data and make some predictions based on it, have a very specific implementation, a very specific way of operating. So they need to have algorithms to represent them, and there are quite a few different ones. So to take one example, let's look at decision trees, which is probably the first one you'll learn if you do go down this route. So it talks about what decision trees are, lots of background information, some of the maths involved too. And eventually we end up with some pseudocode for how this algorithm works in a kind of formalized way. So you won't necessarily understand the content here, you'd have to read more of the context, but there are constructs here you'll notice are the same as the ones you'd be using. So we've got a function, we've got the name of our subprogram, or the function in other words, we've got parameters, we've got a return value, we've got if-else statements, we've got a for loop, and variables and so on. So it does look a bit different, but it has the same core concept. And this isn't a language, this is pseudocode. It's not, you wouldn't be able to have some of these mathematical notation in an actual programming language. You'd have to convert it somehow. I know this looks quite complicated, but really this is a simplification, because this is essentially the Python implementation. Just if I scroll down, you can see it's a lot longer and requires a lot more repeated code and code that is specific to Python. So the Java version would look similar but wouldn't be exactly the same. And also this includes things which aren't really relevant. So how you predict using this, how you load in a data set, isn't really relevant for how this works, its operation. So the core of it is just expressed here. It's not, none of the sort of background things you have to do to prepare it are involved. Writing in pseudocode is much more useful than writing in a particular language, not just because of the length, but this was written 30 years ago. Who knows what programming languages are going to be around in 30 years? It's better keeping it in an abstract form. To give another example of real-life use, you may or may not have come across scientific papers before. Scientists do research and they want to tell people about it, and they do that by, or in most cases they do that by writing papers, which are very structured document, and they get published ideally in journals. So you submit them to a journal and hopefully it will get published. So this is one about machine learning and network security, so on a similar theme to the AI textbook, and they're proposing a algorithm, and part of it is here. So this is an example which isn't really pseudocode because it's too high level. Pseudocode is meant to look like program code. You're meant to be able to convert it to program code fairly easily, whereas here it's more just like a few statements. So it's saying collect historical data from state estimator. That's not really a program like statement. Whereas just below they've got a slightly more pseudocode like one, so a second different algorithm, which again at first glance looks different to what we're dealing with, but actually has got the same kind of structure, even if it uses the same sentence as the one above. So we've got an input, we've got some variables we're initializing, we've got a while loop, and we've got an output in the form of a return value. So similar sort of stuff to what we're doing in our pseudocode. Again, the content, you'd have to read a lot about what's going on. I have no idea what's going on, but you could convert this if you wanted to and you took the time to read what they're proposing. Again, they could have written this in Python or Java or Visual Basic or whatever, but that massively limits its usefulness because someone reading this could not know that language or may not be a programmer at all. They want to be able to understand what's going on regardless of what knowledge they have about programming. Hopefully that's given you a bit of a window into how pseudocode is used outside of exams, but I know a lot of you are focused on exams, so this is a past paper question from AQA GCSE, the old course. And it's a pretty standard one, a pretty easy one I have to say. It's a fairly easy 7 marks. I chose this because I want to focus on the actual writing rather than the problem solving parts, which should be the more difficult bit. But we've got to write an algorithm like this standard question using either pseudocode or a flowchart. We're obviously going to do pseudocode. They don't always tell you to do this. They don't always include this little clarification. So I'd suggest when they don't, you still do it in pseudocode anyway. I would definitely recommend pseudocode over a flowchart. For problems like these, we are hoping you're going to answer it in pseudocode. You can use a flowchart if it doesn't say not to, but I would prefer people use pseudocode because it's slightly more designed for that. But anyway, so this specific problem is about calculating the amount of fuel a train will need to complete a journey. And they often break it down into bullet points, which is really useful because it's often in a rough order. So first of all, we need to ask the user how many kilometres this journey will be, and only continue if this value inputted is greater than 0. We're then going to set the amount of fuel to a number 100 times greater than the number of kilometres, and not allow this amount to be less than 1500. And then we're going to display this amount to the user. So like I say, relatively straightforward, but if I can just talk you through the kind of, or how I would approach this from the writing point of view. Well, I tend to do 3 things when I write pseudocode. First of all, I tend to capitalise my keywords. And the keywords are kind of parts of your commands, but aren't the real body of the command, if that makes sense. So things like if, while, I tend to capitalise Boolean values. So these are part of a command, but aren't, or they're there for the programming language essentially. They're not really part of this problem. I'll also do indentation. So I will indent when I do nesting. So nesting is where you put a control structure within another control structure. So if you had if and then you did a while loop within the if block, you have a little nesting bit, you have a little indent here to make it clear that this is within this block. You know, it's not always clear otherwise. If you've done Python, then you'll be used to this because you have to. Other languages you don't have to do indentation, but it's definitely recommended. I will also I do what I would describe as closing off blocks. There may be a technical word for this which I don't know, but it's where you have, say, an if block and then we're going end if at the end to signal that we have finished this. And the indentation will also show this, but it's useful to do this. And all 3 of these are really for clarity. We want to make it as clear to the examiner and actually clear for us as well. It's easy to get confused. You don't want to get confused in a stressful situation, which is what an exam is. You want to make it as clear as possible and as readable as possible. So let's get rid of all of this and actually answer it, because it may make more sense when I actually show you. We need a couple of variables here. We need an amount of fuel variable. We also need a how many kilometres variable. And we want to initialize that. That's usually the first thing you do when you write code. So let's do amount fuel. And it's really useful to do what you would call descriptive names for variables. So I also will do camel case. seeing as we're talking about actually the writing, I'll do lowercase for the first word and then uppercase for the second word. They're conjoined, so this is one word in a sense, but clearly it's telling us two things. And then I personally will show my variables as an equal sign. A lot of people in pseudocode will do a little arrow, so they'll have their identifier here, i.e. the name of the variable, and then they'll have an arrow and the value itself. A lot of people do that, I think mostly because equals implies a comparison. I personally will use two equal signs as a comparison because program code will often do that. But again, these are the sort of decisions which are really up to you. You can do an arrow, you can do an equal sign. I'm not sure what else you can do. Oh, some people do set your name ID to 0, something like that. Again, it's up to you. I think an equal sign is perfectly serviceable, so we'll do that here. And we don't know the amount of fuel yet, so we'll just set this to 0. It's good to initialize it to a value. We then also need this how many kilometers one. So let's just say kilometers as our name. And then we need to, we could do 2 steps and initialize this to 0 and then do an input, but we could just try and combine it in one. So we could just do inputs here. So by keywords, when I say I capitalize keywords, this also includes built-in functions. For me personally, I'll do in capitals. So an input is a built-in function. So we've got the function name, input, and then we've got the parameter we have to put in. And this will be, for an input, a question. So how many kilometers, and the user will answer and it will get saved in this variable. Again, this is another step which is kind of up to you. I think this is the easiest way to do it. And this is a step which will vary depending on your language. Different languages handle input differently. But this is quite a simple way of expressing it in just one line. In actual program code, it may take several lines and it may take quite a complicated function call to get this result. But this is a fairly easy way of doing it. And the whole point of pseudocode is that you can simplify those awkward little programming oddities like having to do with inputs. This is a pretty simple way of doing it. We're only going to continue if this value is greater than 0. So let's just do an if statement to do this. So if kilometers is greater than 0, and then I would do then capitalized. You could do a colon, you could just leave it, but then I would indent. You could also do brackets, up to you. So if kilometers is greater than 0, then we're going to continue with the rest of this program, and I'm going to do a little indentation here. So now we need to set the amount of fuel to a number 100 times greater than the number of kilometers. So amount fuel, it's going to be 100 times the kilometers. So 100 times kilometers. And here I've used the actual symbol. Often, well, you can't really do this in programming language because we don't have this on our keyboards. So often in programming it will be a little star. You could do that if you wanted to, up to you. It's easier just to write it as the normal multiplication sign. But when we have this caveat here that the amount of fuel can't be less than 1500, so we need to have another if statement which is going to be embedded in this. It's going to be nested in this larger if statement. So we need to do another one here, and we've got to be careful to keep our indentation nice and consistent. So if amount of fuel is less than 1500, we're going to actually set the amount of fuel to be 1500 because that's the minimum. It can't be any less than 1500. And notice how you've got to be quite careful to be consistent. Ultimately, it's up to you. All these decisions are up to you, but you've got to be consistent. So once you make the decision to use if then, you've got to then use it throughout. You can't just drop it because it will look a bit funny. So now I would, like I say, this is me closing off my block. So I'd go end if, and this is for this block. I've done it in blue to try and make it more obvious, but then we've got another wider one. We've got to go through each level of nesting. In fact, I was a bit premature then because we need to actually output it, and this is still within our wider if body. So we need to output amount fuel. And then we can do the final end if, and that would be it for our algorithm. Output is another example of where we can make things a bit easier. So in some languages it's relatively, output into a console is just as simple as doing print and then whatever you want to output. Other languages you have to do all sorts of stuff like system out console, It can be quite long sometimes. So this is a nice way of simplifying it again, like with input. This is a built-in function in our made-up language. But that would be it. So this is a relatively simple way of doing it. There are lots of ways you could do this differently, as I've sort of pointed out throughout. You don't have to capitalize it. I do think capitalizing it is important because you may get confused. It's useful to be able to differentiate between a variable name, which is all in lowercase, and a keyword, which is in uppercase. The exception might be where you have a constant. Constants are often written as capitals just by convention, but usually it's nice to have this distinction between them. Also, the indentation, it makes it really clear how this nesting works, and it removes any ambiguity, which is where an examiner could take your code in multiple ways depending on how they interpret it. It's nice and clear here that this is a separate loop. It's a separate if statement within the wider if statement. If we didn't have indentation, if we kind of shifted this across to here, it might not be very clear that it's meant to be within this. So the nesting is only really clear once you indent it, and I think also closing it off helps demonstrate that too. Here are two possible implementations of the algorithm for pseudocode we just wrote. On the left we've got C++, on the right we've got Java, and their core code is very similar. It's got to be to fulfill this task, but there are differences that are specific to each language. So for example, we've both got to import some external code, we've both got a main method, we've got a class in Java, and the inputting and outputting is a little bit different. We've got a weird chained command here to try and get it to an integer and retrieve the input from the user, and we've got different output statements as well. So it's a little bit different. These details aren't necessary to convey what this algorithm does. It's the actual core code we care about. So we don't need to include all this stuff when we are writing pseudocode. Notice how both languages use braces to close off blocks. So this is the equivalent of what I was doing before with endif. You could use braces for that purpose if you wanted to, and actually neither need indentation. So you could really mess up the indentation and it would still work. It doesn't care about the indentation, but it makes it look a lot nicer for the user. If you wanted to, you could write this code as your answer to the question we just looked at. You could write actual program code in an exam, and in some cases, in simple cases, that's perfectly fine. But when you've got all this weird sort of boilerplate code you've got to include, it just doesn't make sense to include it particularly. Also, I had to look up this bit. I'd forgotten how to do this, and a lot of programming, as you probably know by now, is looking up stuff because you forget it. So you could just keep this nice and simple. Also, things like having to declare the data type of variables don't need to do in pseudocode. It just can be implicit. Just make your life easier. Think about how you would solve it in your actual language and then simplify it to make things easier. Okay, I want to now give you some tips and summarize some of the stuff I've been saying. So to be able to write and read and understand pseudocode, you do need to know some real code yourself. You need to have learnt a real programming language, and I think that's definitely an issue. If you're looking at some of the stuff we've been doing and don't really know what's going on, don't know what an if statement is, don't know what a variable is, it's important that you go away and learn the basics first. So I learnt Python was the first language I learnt, and I learnt it on YouTube. So if you type in something like Python tutorial or Java tutorial, whatever language you're doing, make sure you ask your teacher, or if not, Python is a good one to go with. Lots of different options. Personally, I learnt using the new Boston's videos. He's actually not this playlist, the old one, so I'm sure this is good as well. This is slightly newer. But you don't need to know all of this stuff. There are 56 videos in this one to take this as an example. Others are good as well, I'm sure. You don't need to know all of this stuff. You don't need to know how to build a web crawler. It's not really relevant for GCSE. And so you can stop at reading and writing from files. For A-level, you do need to know a little bit more. You need to know about object-oriented stuff, so classes and objects, that sort of thing. But again, not all of this stuff is relevant even at A-level. So you don't need to go too detailed. You just need to understand the basics, and then you can, it would make more sense when you're starting to write pseudocode, because you know what actual code looks like. And also on my channel I have, so these are the playlists I've got to take paper 2 as an example for VOCI GCSE. There are programming parts on my specification, so I've approached the theory. I haven't made programming videos like these yet, because there are so many out there. I feel like it's a bit redundant, but I have made ones which cover the theory, right? So this will help too, I think, and this is specific to your courses. So this is, this is a much more general approach, but it's still really useful, and this is honing it in a little bit. And hopefully the combination of the two will make things better when you're writing pseudocode. You'll know where to go from. To really re-emphasize this, make your pseudocode look like real code based on your learning from point 1 about actually going away and learning real programming, but simplify. Don't include all the weird little things which are unique to each language. Make it as general as possible. You're not going to get good at this stuff overnight. You've got to do some practice for it. In the case of learning real programming, you really want to be finding some problems to solve and just doing it in a practical sense. Here it's more written and more formal. You've got to go through past paper questions to do this. And also in the description there'll be a link to a bunch of longer mark algorithm questions which require you in most cases to answer using pseudocode. That will help you. They're also all quite similar, so by doing lots of them it'll become more and more automatic, which is really useful. So that's definitely a big recommendation. I'm sure I've said this before, but it's important to be consistent with your pseudocode, right? So there's no syntax, so you can kind of choose what you're doing in a sense that you might choose to use an arrow to assign data to a variable. But once you do that, make sure you're consistent. Don't suddenly switch to an equal sign. This code here, don't worry about what it doesn't do anything, but you might want to pause and see how many inconsistencies you can spot. So this isn't a good example of whatever this program is trying to do, because, for example, we've got print in capitals here, we suddenly switch to an output in lowercase, we've got quotes around our string here, we don't have a quote around our string up here. Lots of inconsistencies, and maybe one an examiner would forgive you for, but if it's a litany of errors and inconsistencies, they can notice and mark you down. So make sure, if once you choose to do something and the choice is yours, just stick to it and make sure you're nice and consistent. And my final point is that make sure you realise that your code isn't actually ever going to get run. So don't worry too much about it, right? It's not worth stressing about. This is just a simplification of real code. It's not a separate language. It's not ever going to get run. There isn't a set syntax. You can do what you want essentially. As long as you're consistent and are nice and clear, then whatever you write is going to be absolutely fine. So hopefully this video was useful. If you have any questions or suggestions, or maybe you've got your own method, let me know in the comments. I'm always interested to hear what you've got to say. And otherwise, good luck for your exams.